Okay, so what we are going to do is, again, we're going to go over a few chemical reactions. So I'm going to tell you what it is via word form. I'm going to write the word form down and then just, again, copy it. And then I'll have you write down the observations here. So the first reaction that we have, and I'll pour these things out, is silver nitrate. And silver nitrate, put my goggles on here. Silver nitrate, when I pour this out, it looks clear and colorless. And I'm going to ramp up the concentration. This is also silver nitrate, but it's a little higher concentration, so there's a little bit more silver nitrate in here. But again, as I pour this out, even though the bottle looks kind of that grayish, dark color liquid, the liquid itself is clear and colorless. So what I'm going to do also is I'm going to place this piece of copper. This is just copper wire that I got from, or you could get from the hardware store, and I'm going to place it in there. So before we even get going here, we're going to have copper metal placed in a solution of silver nitrate. And what I want you to do here is you can write down or jot down this statement right here, and then underneath that, I just want you to put a few initial observations. So again, silver nitrate is a clear, colorless solution, and then the copper has this shiny, dark brown. Somebody with more art skills than me can describe actually what the color copper is besides copper. We have those observations. And we will see a reaction pretty quickly, but we're going to review that again at the very end. So I'm going to show the video here just so everybody has it. Again, silver nitrate, clear and colorless, and my copper has this shiny metal. And so all I'm going to do here is I'm going to take the copper metal that I've spun around a pencil here, and I'm going to place it into the beaker of silver nitrate. And I'm going to give it just a few moments to start the reaction, and then I'm going to pass it around to each of you, and you can kind of write down your observations. So again, we'll let that sit for a few moments, and then we'll start to see the reaction. And it is happening, but it is one that from start to finish takes a lot longer to develop. So all I'm going to do here, and it's already started, is pass this along. And again, you saw the shiny metal. Pass that along, and just look at it, write down some observations. What is happening to the metal? Is there anything happening to that liquid solution there? So the whole point of all this is you can see something's happening. That's the whole goal of a chemical reaction. Hey, we know something's happening because what we started out with is definitely different than what we have right now. And this reaction I'll probably take about the whole class period here. But just to show the camera here, you can see the copper is already starting to get gray there. But what we want to figure out in chemistry, and this is why we balance chemical equations, is what specifically, what are the details of what's happening here. So we start out here with our chemical equation, and we start out with our first thing that's listed. So copper metal. Copper metal, if we look on the periodic table, has what chemical symbol? Cu. And now one thing that we always have to do, I've marked this in notes, but does everyone see the 7 that are kind of scratched out, starting with nitrogen all the way down to iodine, and it forms that 7? Those elements plus hydrogen, if they're listed by themselves, have to be what we call diatomic, or have to be listed as diatomic, which means we can't just put one of them, we have to put 2 of them. So is copper, Cu, one of those elements? No. And so all we have to do, if it's an element by itself, is put down that symbol. So we put Cu because that was our copper metal. And then we get to silver nitrate. So silver nitrate, how it's written, shows us that it is a compound. And so we start out here with the metal, and the metal silver has what symbol? Kind of a weird one.
Ag.
Perfect. So we have silver metal, and now whenever we have a metal and a non-metal, like we do here, we need to figure out charges. So silver, the easiest way for us to find silver is to look it up in that chart that says ion formula chart, which is like 3 or 4 pages into that periodic table packet, and find again Ag and silver, and somebody just shout out what the charge of Ag silver is. Should be
Ag plus.
yeah, there we go. All right, so I'm gonna call this 1 plus, just to help us out with a charge number, actually, but yeah, just be plus there. And then nitrate. So nitrate, you can look on the periodic table, you're not gonna find it. Nitrate is what we call that polyatomic ion. So remember, it's many elements grouped together, many atoms to form an ion. So nitrate, what's the formula for nitrate? Yeah, Ryan?
It's green.
Okay.
I'm not sure.
So we are, what is the first element in nitrate?
Nitrogen.
Nitrogen, yep. And we have one of those, so we have N, and then what's the next element?
Oxygen.
And how many of those, little number, do we have besides?
3.
Perfect. Okay, so the formula for nitrate is NO3. Now, the charge is in that upper right-hand corner, and so for nitrate, what is the charge?
-1.
Perfect. And now, the easiest way to produce our compounds, or produce the formulas of our compounds, is just to make the charge number the subscript. So what that means is for silver, because nitrate had a 1 minus charge, this means we need just one Ag. And Ag also has a 1 charge. So this means we need to keep nitrate as a group, and because this whole group, because we only need one of them, we do not need parentheses. So because we only need one NO3, all we have to do is write down NO3. questions on the setup of the equation? So that is just our starting stuff. Now, we know that that copper metal is not copper metal anymore, and we'll pass this around here in a little bit. But now that gray that we saw is starting to form a fuzz. And eventually this will keep reacting. But what happens here is because there's a chemical reaction, and we saw it, we know that a metal should bump out a metal. So now, what happened here is our copper and nitrate are combined together. And I don't expect you to know this, but what happens here is when copper and nitrate form together like we have here, we get a compound called copper 2 nitrate. And so right below that, we know the symbol is Cu for copper. And now we have to worry about the charge for copper. So what does the Roman numeral mean for the charge? What could we assume if a Roman numeral is written right after a metal? Yeah, it's the charge. And if you're second guessing yourself, look at the ion formula chart. So that is the charge. That means we have a 2+ charge for copper. And then nitrate is still the same nitrate, and it is NO3 with that 1- charge. So again, we crisscross the charge numbers to have our subscript. So that means we need how many coppers? Just one, right? The charge number, 1- means we need one of those coppers. And then nitrates. We crisscross the charge over here, charge of 2+. So that means how many nitrates do we need? 2. Now, again, think of nitrate as a big chunk. And so that means because we need 2, we got to keep that big chunk all together, NO3. And then outside the parentheses, we can put that 2. Now we're not quite done here because we have to figure out what is forming. What is this gray fuzz right now forming? Well, that's our other metal. So copper, what we call replace silver. Silver is now all by itself. So again, silver, if it's all by itself, we always got to double check, is it one of those 7 that have to be diatomic? No. So silver can just be written as Ag. Now we're getting closer here. We need one more step, and that is to balance. So again, with balancing chemical equations, we're trying to account for, hey, something's happening, but we're not losing any atoms and we're not gaining any atoms. All they're doing is they're switching around partners. They are forming new compounds or forming that, in this case, a new silver solid. This is to say, hey, we have equal stuff at the start as we do at the end. So nothing got gained or lost here. So we always start with something on the reactants. And again, it does not matter. I always just pick the first thing I see. So I see copper. And how many copper atoms do we have here? What's that? 1. Yeah. So how do we find that? Remember, we look for the subscript number. If there is no number, we assume 1. We multiply it out by the coefficient. Again, no number, we assume 1. So 1 times 1 is 1. We go over here to the copper. And just the copper, we have how many on the right-hand side? 1, so they're good to go. We move on to our Ag silvers. How many Ag silver do we have? 1 on the left, and how many on the right? 1. All right, so we're good so far. And now we get to our nitrates. So we kept it as a big chunk here. And so what I want you to do is it side and they're the same big chunk, keep it together. So now we only have to count one thing. So just the nitrate, how many NO3s do we have just right here? Again, NO3 counts as one. So we have how many on this side? We have one, and then now this big chunk of NO3 on the right has how many? Two. So we have to put a subscript to make this NO3 on the left a 2. And so all we do is we put a 2 out in front, and that makes NO3 a quantity of 2. But this has affected our silvers. So we now have how many silvers in our formula? So this means we need a coefficient of what over here on the right? 2. Now I'll tell you this is balanced, but if you're second guessing yourself, you can always go back and count. Okay, how many coppers do I have? How many silvers do I have? How many nitrates do I have? And you can kind of keep things straight in your head. Questions on this one? Okay, I want to pass this around. We'll pass this again at the end, but you can see some additional changes. It was just like a gray wire. Now it is kind of like gray fuzzy wire. And so I will set up the next reaction as you start to get that all passed around. Video. Okay, everybody was able to see the silver. What's happening? That fuzzy stuff is actually the silver starting to form here. So I'll show the video, and then we'll get to our next reaction. So again, to show the video here, the fuzzy stuff I'm talking about is the silver forming in that solution. All right, so I've done this one a lot if you've been in my class before. And so what I have up here is just soapy water. And so that just allows me to create bubbles. What I also have here is the Bunsen burner hose. And what happens here is if I turn the gas on, this is natural gas, we can get methane bubbles to form. So all I need the water and the bubbles or the soap for is to form bubbles. And there will be kind of an odor because natural gas doesn't have a smell to it. And so if you leave your oven on, that's why you smell that, and it's to alert you, hey, turn it off. Yeah. Yeah, absolutely. So again, all I'm doing is I'm filling and I'm getting methane bubbles. So what happens here is this.
So basically it'd be a bad idea to light a fire near that?
Well, we're going to light it anyways.
Oh, you are?
Oh, yeah. Oh, yeah. So we're going to take the bubbles and hopefully they don't all escape like they do. But we have methane in these bubbles, and when we light it, we're going to combust the methane. So my hand didn't get burnt, and we'll talk about that. But we can blow that up a little bit more because it goes really, really quick. And if you're wanting to, you can grab some bubbles for yourself. It doesn't hurt as long as you just grab the bubbles. It doesn't hurt that bad if you grab the soap.
Yeah, we can light our hand on fire, basically.
Yeah, you want to try it?
Yes.
Okay, so, like I said, most of the bubbles will pop, but come around, reach in here, and just kind of get a big handful of bubbles, and you probably have to, there we go. Perfect.
Oh no.
Oh no. Okay, so grab down, kind of by the water here. Perfect. All right. So, again, what happens here is we're just going to help speed the combustion up. So we're going to react the methane with,
I'm scared.
oh, you'll be good as long as the lighter works. So again,
Ooh, it's a little warm.
so it gets warm, right? So you get your combustion, but your hand's not burned. Anybody else want to?
Yes.
Yeah.
I'm nervous.
So again, bubbles. I probably got it too soapy today. It seems excessive, but as many bubbles as possible. Alright, so what you do on this one, Skylar, just grab the bubbles, yep, and a lot of them will pop.
Yeah.
Holy cow.
Oh no.
I'm gonna help us out a little bit here.
Yeah, I was gonna say that's kind of a lot.
Let's pop. Oh, yeah. Okay, try grabbing again. That was a good grab
my
if
God.
I wasn't concerned. Okay, so again, we're gonna help with the combustion here. And you feel warm, but everything gets combusted.
What
Perfect.
the heck?
Alright, so let's talk about this one real quick, and then if we have extra time at the end, I'll let anybody who wants to do this here. So I'm gonna pause the video and change it back to the board. Okay, so we will erase what we have here, and this will be the second reaction that we did here. And again, methane, which I know all of you studied organic chemistry, but methane has the formula of CH4. And again, I don't expect you to know that. If I said methane, I would help you out with the formula. But methane combusts with oxygen. And so I know the reaction was relatively quick, but if you could write down a few things that describe what happened when we actually helped spur along that combustion with oxygen. Again, we had, for those, Skylar and Ryan who did it, you had that real quick heat, you had light, and obviously the methane is no more because it's not in your hand anymore. And now the bubbles were just from the soapy water, so it's kind of like an additive thing that we did. Alright, so as you finish up writing here, again, we want to balance the chemical equation. We want to figure out what happened here on the flame bulb. So we start out with methane, which I told you was CH4, and now methane was the gas, G for gas, inside of the bubbles. Again, the soap helped canvas or encompass all of that methane. Now it says, hey, it combusts with oxygen, so that's our other reactant. Now, again, if something is ever by itself, if an element is ever by itself, we have to check out and we have to say, hey, is oxygen one of our 7 diatomic elements? Yeah, it is one of the 7. So if we see oxygen just by itself, not with a compound, but just by itself, it can't just be O, it has to be O2. Now oxygen is a gas, it's what we breathe in and out, help us go through respiration. And so we had 2 gases combined together. Now we help spur it along with that heat to get that combination. Now, for Ryan and Skylar that actually went through it. It got warm, right, because you had the bubbles, but did you feel like your hand burned at all?
No.
No, I mean, it definitely is warm. The reason why it's just warm and didn't burn is what happened. As the combustion happens, we get two and only two products in this type of reaction. One is carbon dioxide gas, which is what we exhale, right? So it's not dangerous. And then two is water vapor. So it's just H2O as a gas. And both of those things, because this happened really, really, really quickly, both of the carbon dioxide and water vapor went up towards the air, because that's what gases do when they get hot. And so that heat and those other things went away really, really quickly. And so that goes with that heat rises. Now, we're not quite done because we need to balance the chemical equations. So, again, I always pick the first thing I see. We have how many carbons on the left? Just one. How many carbons on the right? One, so we're good to go. We move to hydrogens. How many hydrogens on the left? 4. How many on the right? 2. So what coefficient, what number out in front do I have to put? 2, right? So we get 2 times 2 to get us to 4. Now we have to count our last thing here, our oxygens. Oxygen on the left, how many do we have? 2. Now we have to be really careful because on the right, oxygen is in 2 different places. So we have CO2, there's 2 oxygens, and then 2 of the H2O. So how many total oxygens on the right? 4, right? We get 2 from CO2 plus 2 times 1, we get another 2. So that's 2 plus 2, that's how we get 4 on the right. Now we need to think to ourselves, what times 2 gives us 4? 2. So we are balanced, and again, the nice thing about balancing a chemical equation is that we can go back and double check. Questions on this one? Okay, let me shut my phone off here. Huh. All right, the last one that we're going to do, it's really quick, and it's actually pretty easy to balance. So I'm going to put my goggles back on. And so what I start out here is going to be with sodium hydroxide. So we're going to have sodium hydroxide as our third thing here. Sodium hydroxide. And sodium hydroxide, again, is just clear and colorless, very similar to silver nitrate in terms of the way it looks. And what I'm going to do here, just pour it out, and then I'm going to put this universal indicator. And now, universal indicator is like chemistry food dye that allows us to see what the pH is, or how much acid or how much basic level it has. So here, when I combine it with universal indicator, it has a very dark purple. So I'm going to put sodium hydroxide with universal indicator. Now, what I'm going to do is I'm going to combine it with hydrochloric acid. So again, hydrochloric acid is a really strong acid. And so what I'm going to do, I'm just going to add a little bit at a time. I'm going to stir it up, and I'm going to see what happens. So a little bit, still really purple. I'm going to add a little bit more. And now, what has happened is this. We've gone through a color change, and I added the hydrochloric acid really, really fast. So again, in our minds, hey, if the pH is adjusted, we've most likely had a chemical reaction. And you can pass this around here. Again, this is much, much different color because we've added the acid. And so as we're doing this, I'm going to write this down. So With universal indicator combines with hydrochloric acid. Now, to save time here, I know we're running close. To save time, sodium hydroxide has the formula NaOH. It combines with hydrochloric acid, HCl. What happens here, and again, to save time, I'm just going to go through it, is they switch partners. They switch those plus and minus partners. So now sodium and chlorine combine together. And if you combine sodium and chlorine together, you get the compound NaCl. Now, H and OH combine together. And I'm going to write this down here. H and OH. What can we condense those H's to? Or how many H's? Perfect, right. Whenever you see H and OH, you just have H2O. Now, you can write down a few observations here, but do we have to do anything to balance this equation? No, so this is balanced right here. So write that down. You can just leave those on the desk. I'll pick it up, and then I'll get you 10 easy points in the grade book there. Questions? We ran a little long here. All right. And then you can look at the silver ions as it's formed. Again, just leave it on the desk. I'll grab it. Show the video here. This is the red solution after we added the acid to that sodium hydroxide. To show the video here, this is the final product of combining copper and silver nitrate, and so that sparkly shiny stuff is the silver that has been produced as a solid.